So in our last section, we're still going to talk about hypothesis testing, but we're going to do one sample test for the mean. So again, we're just going to outline the basic steps in a hypothesis test, and it's going to look similar to what we found for a one sample proportion test. So our basic steps in a hypothesis test, first one, right, state your significance level. So we tend to have, three most common ones, 0.01, 0.05, and 0.10. Again, we like to state the significance level at the very beginning of our experiment before we actually go through and do any data collection. Our null and alternative are going to look really similar to what we saw before, right? So our null is going to be mu equals, right, mu naught. And then my alternatives, right, so we have sort of different cases. We could have mu does not equal mu naught. This would be a two-tailed test. We have, right, HA could be mu is greater than mu naught, so that would be a right-tailed test. And our last one, right, the null or the alternative could be mu is less than mu naught, and this would be a left-tailed test. And remember, we have the null, and then all alternative is just going to be one of those, right? So we could have right-tailed, left-tailed, or two-tailed test. The next thing that we tend to do is calculate the test statistic, right? So our first check that the following assumptions are met. So a random sample of size n is taken, and the distribution of the random variable is normal, or the sample size is 30 or more. If both of these are true, the next step is to decide which statistical test to use. So we have, right, basically a Z or a T test. So it says if you are doing a hypothesis test for one population mean. So if you know the population standard deviation, right, that's what this first one is. So either the first case or the second case. So we have the population standard deviation. If we know the population standard deviation, we are going to use a Z test. And you can see our formula. If the population standard deviation is unknown, and so sometimes there's confusion, we are always going to be given a standard deviation. We just have to determine, is it a population or is it from a sample? So let me highlight so you can sort of see the difference. For the first formula, right, we have sigma. The second one, we have S. So with this one, right, we have the sample standard deviation. So we don't have the population standard deviation, we have the sample standard deviation, and then we are going to use what we call a t-test. Now, probably using a t-test is more common because most of the time, if we have we don't have the population standard deviation. We probably have all of the information coming from the sample we collected. So most of the time we use a t-test, but the basic distinction between a z and a t is what type of population standard deviation do you have. So to determine the, which distribution to use, then it says determine the p-value for the test, right? And so if I'm thinking of the tailed that I have, so let me just draw my three curves here, one for each of the tailed test. So if it's, right, so here's my mean of 0, right? Here's the mean. Let's say, right, here's my p-value. So here's my standardized test statistic. So it could be a z or a t, right, just depending on the distribution you use. But here's your p-value, right? You could have, for a right-tailed test, right, so maybe your p-value is over here. And this would be the z or the t, right, the standardized test statistic. And then if it's a two-tailed test, right, we're looking in both of the tails, right? Here's the p-value added together. And again, it could be negative z, negative t, positive z, positive t, just depending on the distribution. So fifth one, we would compare the p-value to the significance level. 6, we would decide or not, right, whether reject or fail to reject the null based on the p-value. And then we write our conclusion, right? the conclusion would read, at the percent significance level, the data provides, or it doesn't provide, sufficient evidence to reject the null hypothesis and conclude the alternative hypothesis is true. Or there is not enough evidence at the alpha percent level of significance to show that, and then state the claim that was made, right? So again, the way we write the conclusion, it just sort of depends on, do we have it as a multiple choice or are we writing it by hand? So as long as it sort of says both of those, all of the different elements, we should be good. So those are our steps to figure out how to do a one sample test for the mean.